Hello friends, in continuation with the last lecture, today we will talk about the last topic of this chapter, that is dead weight tester method for the measurement of the pressure. So this kind of the methods is used for the actually pressure measurement instruments calibration. Okay, how it can be just measured? It is to be the process of the adjusting the instrument's output signal to match the known range of the pressures, so that it can be easily calibrate the machines with a very high accuracy. Basic calibration process actually it includes the zero, then span, and linearity adjustment. So already we know the definitions of these all three properties or the characteristic of the instrument. For the calibration purposes, generally hydraulic or the pneumatically operated dead weight tester methods are used. Hydraulic, generally fluids are used for controlling the pressure, or pneumatically the air is generally used for applying the pressures. Now here you can see the schematic representation of the dead weight tester method. You can see over here that is the gauge is shown over here. Then the weights are placed on the platform, and which is just putting over the piston, which is a frictionless piston in the one of the cylinder, and then there is another oil reservoir is there, having the some similar kind of the cross sectional area, surface area, both will be having on which we will just try to apply the uh, pressure, and then or by just trying to have the is a oil reservoir for the sake of the understanding the pressure difference between these two cylinders. And then there will be the place where the screw plunger will be there, through which we can apply just to while just moving the handle, we can apply the pressure easily, and the direction can be shown over here. So a check all which shown as well. So the dead weight tester method consists of the two accurately machined cylinder. Okay, two accurately machined cylinders are there, and then the inserted into the two closed and the known cross-sectional area coupled together to the reservoir. So their cross-sectional area is known, and they are coupled together to the oil reservoir. Now, one of the two cylinders fitted with close-fitting frictionless pistons with the top platform. On this platform, accurately known weights in the form of the disc are added over it, and so that it can just apply the pressure on the through that platform. So the pressure transducers to be tested is connected to the another cylinder over here. Now the screwed plunger is provided to the reservoir to apply the pressure to the fluid. The fluid pressure is gradually increased by a screw plunger until the force is large enough to just lift the precision weight combination. Here, when the piston is floating freely, the piston with the weights is in the equilibrium with the pressure developed in the cylinders. Now you can see over here that when we apply the pressures over here, then obviously this piston will just try to flow up. But if we just add the weights over here, because we know the cross sectional area of it, and if we add the weights over here, then we know the force by just knowing the formula as the F is equal to mg, and then if we just the levels of these two cylinders will be same, then it will just float over, the piston will float over this fluid, and the pressures will be can be easily calibrated with the known pressure, because here we have the known pressures, and unknown pressures can be calibrated over here on this pointer, the gauge under the test is attached over here. Now, the pressure can be expressed as P is equal to F of 1A. F is nothing but the force mg, that is gravitational force. M is a mass, and the g is the acceleration due to gravity, or the gravitational constant. Uh, is equivalent force of the piston weight combination, and the A is a cross sectional area of the cylinder here. the same pressure is applied on the transducer connected to the another cylinder. Similarly, by just changing the weights appropriately, the sensors can be calibrated to a high order of the accuracy. So the advantages of this method is that it can be used in a high precision measurement with accuracy as high as 0.01%. So the mostly this type of the methods are used for the calibrations of the gauges. So here it completes our module number 3, that is measurement of pressure. Thank you.